Today's video, we're going to talk about solving radical equations. You did see the beginnings of this in your video notes yesterday, so hopefully this first part will sound familiar. The steps for solving a radical equation are a lot like the steps for solving an absolute value equation from last unit. The first thing you need to do is isolate that piece of the equation that you're trying to fix, that you're trying to get rid of. So we're going to isolate the radical, the square root. And I did put an example here where you have to be a little bit careful. Subtracting 3 from both sides is easy. Just be real careful about this negative. It is very, very easy to overlook that negative, so please be mindful of that. That minus sign, it comes down. We haven't gotten rid of it yet. If I want to get rid of it, I would need to divide both sides by -1. And now the absolute value is isolated. Sorry, the radical is isolated. Step 2 is to get rid of that radical, and just like with the absolute value, the magic trick was to separate the absolute value into the two possible solutions, possible equations for the square roots. The magic trick is to square both sides. It makes a lot of sense that if you square both sides of an equation, you'll still have an equation, because if two numbers are equal to each other, well, if you square them both, should still be equal to each other. And when you square a square root, the square and square root cancel, and you're left with just the radicand. So the square root of x minus 7 squared is just x minus 7. And then our last step here would be just to finish solving. Just like at the end of an absolute value equation, solve for x, get the x by itself. In this case, that's an easy one step. Just add 11 to both sides, and we have a solution. You do often get extraneous solutions with square root functions, so do a quick check. If you can do the check mentally, that's fine. As long as the solution works, just doing a check mentally is fine. If the solution doesn't work, you will need to show me why it doesn't work by showing the check. This one, though, if you do it in your head instead of writing it out, that's fine. It will work. 3 minus the square root of 11 minus 7 equals 1. Well, the square root of 11 minus 7 is 4, and the square root of 4 is 2. So 3 minus 2 is 1. That works. A quick note about higher roots, because we have to solve cube root equations and fourth root equations and so on. If you have a higher root, the only thing that changes is you're not always going to square both sides. Sometimes you'll have to raise both sides to either a higher or a lower index. So it'll be raising both sides to the power of the index, which is a strange little sentence. Let me show you what I mean. Whatever this index is, that's going to be the power that we raise both sides to. So if I want to get rid of a cube root, I'll cube both sides. If I want to get rid of a fifth root, I'll raise both sides to the 5th power. So that becomes x minus 5. 3 to the 3rd is 27. And then we'll finish solving. Adding 5 to both sides, x is 32. You actually don't have to worry about checking your solutions to cube root functions, to cube root equations. They will always work. Okay. We're going to look at a slightly trickier example now. What happens when you have more than one radical? The process isn't the same. The only issue is I can't isolate everything at once. I've got a radical x plus 2 and a radical x, so 2 square roots there. I can't isolate them both. And ordinarily what I would want to do is isolate the square root. So because I can't isolate them both, what we're going to do is just isolate one at a time. We'll follow the rest of our steps. We'll just have to kind of do the squaring both sides twice. But we have an isolated square root, so I'm going to square both sides. When you square both sides, this is the big thing. Squaring x plus 1 to the 2nd power does not mean squaring the square root of x and squaring the 1. Squaring the whole side means you've got to multiply the whole side by itself, which means you're going to have to FOIL it out. On the left-hand side, squaring the radical does leave us with just plain old x plus 2. On the right-hand side, you have to know that root x plus 1 squared is root x plus 1 times itself, which means you are going to have to FOIL it out. Distribute the root x, distribute the 1. So you're going to end up having to multiply 4 times. Now, there are plenty of shortcuts for FOILing, but unless you know some of those, just go ahead and multiply everything. Square root of x times the square root of x. Square root of x times 1. 1 times the square root of x. 1 times 1. And of course, you'll notice there are still square roots here. So I'm just going to finish simplifying that side by adding those two square roots together. Square root of x plus square root of x is 2 square root of x. And now we've got a problem. I thought I just got rid of my square roots, but there's still a square root. And so what's going to happen here, and this is something that's going to come up, a lot during the year, is sometimes you just have to imagine that whatever you're looking at in a problem is the beginning of the problem. So pretend that none of this happened for a minute. What would you do if the problem looked like that? X plus 2 equals x plus 2 root x plus 1? Well, you'd isolate, square both sides, and solve. So that's what we're going to do. It doesn't matter that we've already done some of that. We always just decide what to do based on what we're looking at, not what we've done already. So I will work on isolating. Go back to my blue color. And isolate. Well, the x's cancel. That's nice. If I subtract x from both sides, they'll cancel. Next unit, we'll learn what to do if they don't cancel, but for now, they're going to have to. And I'm going to need to subtract 1. And that will leave me with 1 equals 2 times the square root of x. And again, I'm not quite done isolating yet. Let me get rid of that 2 first. So the square root of x equals 1/2. And now we're back at the square both sides step again. And this time, a lot less going on. It's a lot easier to do. Square the square root. And 1/2 squared. Keep in mind that when you square a fraction, you are remembering to square both the numerator and the denominator. 1/2 squared is 1/4. And that's our solution. X is equal to 1.